sir.
Hello, Haripriya. In the last class, let me explain that concept in detail. Then we'll start pressure difference in rotating liquid. Did you remember in the last class I have told you two concepts? This one I was going to tell when the container is accelerating downwards, and then pressure difference in the rotating liquids. It's because I have discussed the last one very fastly. Let me go somewhat slow. Let me explain you properly now. Let me draw the container first. This is our container. We actually know whenever the container is just kept as it is. If we take 2 points, one is this P1, another is P2, and suppose they are separated by height h, the pressure difference is given by, first is when no acceleration is there. So let me copy this. When no acceleration is there, in that case we know P2 is equal to P1 plus rho GH is the condition, right? You know this one already. But do you remember how did we get this one? Haripriya?
Yes, sir.
We have taken a container of the liquid and then made it to be in equilibrium. So we made the total forces equal to 0. Then we got this condition. Now what will happen when there is acceleration? When container is accelerating, upwards. In this case, what happens? When this container is accelerating upwards, when you take this one, the container, if you take the container of this one, when you equate the forces, let's say the area is A, the force will be F1 will be equal to P1 into A, the force from the bottom will be equal to P2 into A. What happened to them? They're sleeping or what? Other forces mg, but with that there will be another one more force because it is accelerating down upwards. It will be a pseudo force. See, it's up to you. Either you make use of pseudo force or take the whole system which is accelerating.
Sorry, sir, I got locked out.
Ghost has logged in. I know this is Kanishka. Kanishka, you are the ghost.
Yes, sir.
And then did you see the previous classes? No.
No, sir.
Hmm. I'll send you the link. I'll send you the link of the classes. Watch it. 2 classes were completed.
Okay, sir.
Fluid mechanics. So what we were doing? So in this case, you can do both things. Either you can apply the pseudo force, which will be acting downwards ma, and then you make the equation, which is F1 plus mg plus ma is equal to F2. Or you can do other ways also, because by Newton's laws, if you know, we can make this equation like this also. F2 minus mg minus F1 should be equal to ma. Where is F1? Correct. This is using Newton's laws. Newton's laws, normal equation framing. When an object is accelerating, we take the direction, all the forces in the direction of acceleration as positive and against as negative. Na, Haripriya? You remember? And using pseudo force, and this is
Yes, sir.
using pseudo force. I have applied the pseudo force, and if I apply pseudo force, this will be in equilibrium. So either way you frame the equation, you will get the same equation because they both are same. So it doesn't matter whatever way you do. This I am explaining you because I remember one student asked me this doubt. Sir, why should we apply only pseudo force? Can't we solve using the Newton's laws? I said it's okay. Either way you do, you'll get the same answer. So then, if we make this use of this equation 1, F1 is equal to P1 into A plus what is the mass will be density of the liquid into area into height into G plus A will be equal to P2 into A. A will cancel. So P2 will be equal to P1 plus rho H into G plus A. This is the pressure difference now. So effectively what happened, see this process that I have done, this process we have already done in the first class when I was explaining you the pressure difference due to height. But now I'm explaining because the pseudo force, because this container is accelerating. Why, when it is accelerating upward, why the pressure difference is added up by the rho ah component, that I am explaining you. Understood now? In the same way, if we take this case, the opposite case, when container is accelerating downwards, Kanishka, you watch the recordings. Because I have given you the link in the group. If you have not seen
Yes,
it,
sir, I will watch.
hmm,
I was just busy with my exams.
your exams are there. I know. Now you watch the recording. Otherwise, tomorrow is maths class, so you have time, 2 days time, so you can watch it.
Yes, sir.
Okay. Also in maths, what we were doing, we have started ellipse. So only one class is over for the ellipse. Parabola is completed.
Sir, it's conic section 1, right?
Conic section. In conic section there are three parts, na? 3 or 4 parts. One is
Yes, sir.
circle you have completed. You have watched the classes. You were there in the
Yes,
class.
circle 1, eclipse 1, and one more, I don't remember. Even it has done in my school.
So the
I don't understand that.
parabola one is completed. So parabola one you can watch.
Okay, sir.
Parabola one you can watch later, but before the next class, means before Monday,
Yes,
you
sir.
need to watch that ellipse one, because ellipse I will be continuing. One class of the ellipse is completed and then next part will be started. So if you will join the class on Monday, you won't be able to understand. So first
Okay,
you
sir.
watch that one, ellipse one. Okay, one
Okay,
class
sir.
only 1 hour. If you are, see, because I have given you the link of the videos, you watch there, you look there. If you are not able to find, message me. I'll share you the class link.
Okay, sir.
When container is accelerating downwards, what happens? Let me make the diagram first. Everything will be same, just the pseudo force direction will be different, will be opposite, upwards. So when we make a container, the forces will be like this: P1 into A, mg is downwards, P2 into A from bottom, and there will be a pseudo force, mu force, which will be acting upwards. So if you make the equilibrium, P1A plus mg will be equal to P2 into A plus ma. So, or this is the equation, put the value of mass. So P1 into A plus m, I'll bring a here, m is rho into A into H into G minus A is equal to P2 into A gets cancelled. So you will be getting P2 is equal to P1 plus rho into H into G minus A. This is actually the proof I am showing you, but proof is not needed. If you are able to remember this, when the acceleration is downwards, A will be separated from G. When A is upwards, A will be added with G. That's the only thing you need to remember. right? Now let's move on to the second part. The second part is pressure difference in rotating liquid. Yeah. Did any one of you observe this thing? Whenever you rotate the glass, or whenever uh, there are some devices now, means acha, take a bucket full of water, bucket having some water, try to rotate it with your hand. If you rotate it, the water tries to come out from the ends. Did anyone observe this one? Suppose you are mixing
Yes,
something. Suppose in Holi or some kind of some festivals, I don't know whether they play Holi that much in your place, Haripriya, but in North they do. Whenever we are mixing colors now, whenever we are mixing colors in water, we tend to rotate it. We pour the whole color and then we tend to rotate it. When we rotate it, the water tries to come from the outside, from the corners. And and also, did you see the idli making process? The idli that batter is there, no? Did you observe that one, Haripriya? Did you observe this one? When there is a machine, no, in which
yes,
they
I
put that one,
observed.
and it's rotating. So what happens? This the batter, it tries to come out. It tries to come up. In the center, there is nothing. It will just try to move up from creep up from the sides. That's what I'm talking about. It's rotating when it goes up. That's that we are talking about this one batter, idli batter, because it's thick, so you won't be able to see the curve properly. But when we are talking about the liquids or water, in that particular case, you will see the full parabola, the full curve. Why it happens, that we are going to explain. बिल्कुल कर लोगे. Then what happens? See, now we are going to derive why it happens and why the curve shape is parabola. Because you have learned parabola, you will find out the equation. You will be able to relate this properly. Let me draw the container first. Now, what is the situation? This is the center of this container. There is water, and you will see when it is rotating like this with angular speed omega, the shape of the curve will be like this. They say it is parabola, but till now we do not know it is parabola or not. We'll try to find why it is parabola. Now see, for finding it, what we'll do, we'll take a section, this section of water. Okay, and we'll take a small section of length dx here, which is supposed to be at a distance of x from the middle line, from the center of this container. Okay, let me draw it here for proper large analysis. This is your center axis, it's rotating like this. This is our elemental section. Let's say its length is dx and its cross section area is a. It is at a distance of x units. Now when we are analyzing this one, if the pressure at this point is P, obviously the pressure at the right side will be somewhat more, P plus dP. Why? Because when it is rotating like this, there should be a resultant force towards the center, then only which will be providing, which this extra force dP into area will be providing for the centripetal force, right? Then only it will be able to rotate. That's why I have increased the force on the right side by dP. Okay, now if we make its equation, what it will be? P plus dP into area minus P into area will be equal to m into x into omega square, right? Okay, clear?
Yes, sir.
Okay, now for this element, what will be the mass? Mass will be the density of liquid, since it is water, rho into area into its length dx. A into dx is its volume and rho is the density. Density into volume is the mass. So when we'll simplify it, P will cancel. So we'll get dP into A will be equal to rho A dx into x into omega square. A will cancel it out. So we are getting dP is equal to rho x omega square dx. Now if we want to find out the pressure difference from one end, say here it's P naught, say here the pressure is P1, we will have to integrate this from P naught to P1. Let's say the length of this container is L from to the one side. So we'll integrate it dP 0 to P naught to P1 rho omega square x dx, integrating from 0 to L. P1 minus P naught will be equal to rho omega square x square by 2, 0 to L. You know the integration of x dx, it's x square by 2. P1 minus P naught will be equal to rho omega square L square by 2. So this is the pressure difference for the length L. P naught, why I have written P naught? Because this part, the central part, this part is open to atmosphere. It's at the depth, it's open to atmosphere, and this is open to atmosphere, so the pressure here will be P naught. But pressure here won't be P naught. Pressure here will be P naught. It's open to atmosphere. But pressure at this point, bottom point, won't be P naught. That's why I put the value as P1. If I have given this height h, then I would be able to write P1 will be equal to P naught plus rho GH. That's another thing. But right now this pressure P1 is not equal to P naught. That's why I have written this relation. Correct? So the difference of pressure is this. Now, but still we have not got this curve equation. Now, how to get this curve equation? Let's say for this x distance, this vertical height is y. Correct? Now, if we integrate this equation, this first equation, dp is equal to rho x omega square dx. What will be my integration points? P naught to here. Let's say at this x distance, at this point, the pressure is px. So P naught to px, I'm integrating from 0 to x. It will be px minus p naught is equal to rho omega square x square by 2. Correct? But since px is at a depth y below this and the pressure at this particular point, it is open to atmosphere, top point. So the pressure at this point will be P naught. Now the point where we have found out the pressure Px, this is Px is at a depth y below it. So the pressure Px will be what? Px will be equal to P naught plus rho gy. Correct? I can write this. Yes, Haripriya? Kanishka?
Yes, sir.
See, if you have any doubt, you can just ask me. But I am explaining it very clearly. If you miss out anything, ask me. So from this third equation, I can write Px minus P naught is equal to rho gy. I'll substitute this one in the second equation. I'll be getting rho gy is equal to rho omega square x square by 2. Rho will get cancelled. So x square is equal to 2g by omega square into y. This is the equation of our curve. And if you remember, this is very similar to x square is equal to 4ay type. So g is constant, omega square is constant. It's similar to 4a. So, and this is x square is equal to 4ay is the parabola opening upwards. That's why the curve that we get is parabola opening upwards. Understood? Just try to observe it. Meanwhile, let me select some question for you. But Haripriya understood properly? Let me...
Could you explain the part of the curve again?
Curve again. See, I wanted to get the relation between x and y. Correct? So what I did, I made use of this equation 1. dp is equal to rho x omega square dx. This equation I have. What I did, I integrated this equation from P naught to Px. This P naught to this point Px. Here to here.
Okay, sir.
Length from 0 to x. So I got a relation Px minus P naught is equal to omega square x square by 2. But when we talk about the pressure Px is at pressure Px point is actually at a depth of y below the atmospheric pressure point, which I can write Px is equal to P naught plus rho gy. That's why Px minus P naught I wrote as rho gy. So cancelling them, I'll get the equation of curve. Okay, just observe it. I'm selecting the question. Just try to observe by yourself. First, I'll give you the easy question. Then we'll move on to do the tougher one. The question that they have given, you've already solved it. Okay, now this is the good one. Try solving this. If you want to look at the concept or anything, just ask me, I'll show you. Try to understand and get some idea how you'll solve this one. What happened? You're not getting idea. Haripriya? Kanishka, I cannot say anything.
No, sir.
Hmm?
No, I'm like, I don't know to
See,
what value should I consider L square.
see, I'll give you a hint. If you take the right limb from this middle point, here will be some pressure, no? Some pressure, P. We do not know what pressure is this. But if we move from right side, here it will be P naught atmospheric pressure. Here also it is atmospheric pressure, right? If we talk about here, the pressure will be what? P naught plus rho GH2, correct?
Yes, sir.
Here pressure will be what? P naught plus rho GH1. Let's say it's pressure, let's say it is P2, let's say it is P1. Now we also know that P1 minus P is equal to rho omega square x1 square by 2. Correct?
Yes.
For the left limb I am talking about. Similarly, for the right limb, we know P2 minus P is rho omega square x2 square by 2. So from this first equation and second equation, what I find? From first, P is equal to P1 minus rho omega square x1 square by 2. From second, I find P is equal to P2 minus rho omega square x2 square by 2. What is P1? You already found P naught plus rho GH1. Since these two values are same, PP, can I equate them?
Yes, sir.
So P1, which is P1 minus rho omega square x1 square by 2 is equal to P2 minus rho omega square x2 square by 2. P1, P2 value I'll put here. P1 is P naught plus rho GH1 minus rho omega square x1 square by 2. It was not easy, but it demanded some of your thinking.
I was substituting P is equal to P naught as well.
We cannot take P is equal to P naught. We can only take some pressure as P naught only when the surface is open to atmosphere. Like here, the left limb top surface I have taken P naught now because it is open to atmosphere. The right limb top surface is also open to atmosphere. That's why I have taken P naught. Whatever surfaces are open to atmosphere, we can take as P naught. Now you will be able to get the equation. They have asked the relation between H1, H2, X1, X2. So the relation will be this. Rho we can still cancel out. So omega square into x2 square minus x1 square whole divided by 2 will be equal to g into h2 minus h1. So the relation is this. h2 minus h1 is equal to omega square into x2 square minus x1 square by 2g. This is our required relation. कनिष्का तुम्हें समझ में आया? देखो बहुत चीजें
Yes, sir.
तुम बहुत चीजें रिलेट
थोड़ा
नहीं
बहुत
कर
तो
पा
है.
हाँ, तुम बहुत चीज रिलेट नहीं कर पा रहे होगे थोड़ा बहुत। जैसे मैंने P2 को रो नॉट P नॉट प्लस रो जी एच टू क्यों लिखा, ये सब चीज तो पिछली क्लास से पता चल जाएंगी, क्योंकि वो तुमने मिस कर दिया है ना। उसको एक बार देख लेना, समझ में आ जाएगा। लेकिन
Yes,
जब
sir.
जब भी हम टॉप से बॉटम में जाते हैं ना, तो प्रेशर इंक्रीज होता है बाई एन अमाउंट रो जी एच, डिपेंडिंग ऑन द हाइट, उसके हिसाब से। और ये तो तुमने अभी पढ़ा ही है, प्रेशर डिफरेंस जो मैंने राइट उसमें बताया, रोटेशन की वजह से। अच्छा, अब एक और क्वेश्चन सॉल्व करो। You look at this one, the solution. I am selecting one more question for you. Don't worry if you are not getting the idea, because I'm wantedly giving you these kinds of questions because to make you think, to make you get idea. Because more comfortable you are now, more tougher you feel now will be more comfortable for you later in the class 12th. Attempt this, try this. It's actually very easy. I don't know why you're taking so much time. The only thing you have to take care is omega is given in terms of RPM. So you will have to convert RPM into the radian per second. 2 into 2 pi 60. 4 pi by
So
60.
they've already given in seconds.
Which one?
The rotational speed. It's
Acha. It's in second, na? Okay, sorry. So, but it's revolution per second. So radian per second means you have to multiply with 2 pi. Omega is 4 pi actually. So you know the relation is y is equal to rho omega square x square by 2g. But when we are taking from 0 to this length 5 centimeter, when x is 5 centimeter, y has to be the height h. So h will be equal to rho, which is liquid. Its density is given. Rho is there or not? Yeah, rho, I think I written.
they haven't given.
Rho has not given, and they have not. I think we have to assume water. Rho will be 1 there.
Rho and G gets cancelled out because if you take the pressure difference.
Why?
It's like P minus P1 would be equal to rho G of omega square by 2.
See, I wrote the wrong equation. No? Y is equal to omega square x square by 2g is there. Rho is not there.
Yes.
So y is equal to omega square x square by 2g. So h will be equal to omega square into the radius r square by 2g. It will be omega is 4 pi. So 4 pi square into r is 5 centimeter. So it is 5 square into 10 power minus 4 by 2 into g. And I'll make use of that thing that pi square is g. So 16 into 25 into g into 10 power minus 4 divided by 2 into g will cancel. 4 into 25 into 4, 100. 2 into 10 power minus 2. So it is 2 centimeter. So h is 2 centimeter. 2 centimeter is the answer. Got it? It was not difficult. It was easy only. Clear? Easy? Okay, in the next class, I think the rotation part is done. There are few extra concepts, few small concepts that I'll discuss. That's SHM in floating body, that I will discuss. that's more like a problem rather than a concept. Then we'll move on to the dynamics. Dynamics of fluid. Okay, let's end the class.